Okay. Block and tackle. So can anyone help me out? What was the mechanical advantage of a block and tackle system, and how was it explained? Yes. Can anyone explain, please, children?
So the block and tackle system had three fixed pulleys and two movable pulleys.
No, it depends on the number of pulleys, my dear. It is not always that it is three only fixed
Yes,
pulleys.
miss. I mean that the movable pulley should be less than or equal to the fixed pulleys.
Fixed pulleys. Okay. Then what? After that, what? Yes. Now, till then, I am just taking the block and tackle. Till then, if you all can just tell me how did we express the mechanical advantage? That is important. It was very important. And what was the use of the fixed pulley? What is the use of the movable pulley again? If someone can repeat that? Yes. Anyone who can give us the role of a fixed pulley or the movable pulley?
So the fixed pulley is just used to change direction in the convenient way.
And what is the use of the movable pulley? That is important. It is used to multiply the effort. Remember, what is the use?
Multiplying the effort.
Multiply the
Multiplying the effort. Because see, whenever we speak about movable pulley, the mechanical advantage is two, correct? Single movable pulley. So you are applying effort as one end and it will get doubled. Okay. So multiplying effort is the use of movable pulleys. Now, last time I showed you the diagram of block and tackle also, both the diagrams. Yes. Did I show that?
So don't remember.
Okay, I'll show it again then. Chala. If you don't remember, I'll show it again. Block and tackle. So let me paste it on the screen also. A little suddenly it has started hanging. Just a moment. I'm pasting it. Now it's there. It's come up. Okay, yes. What's coming up? The Chrome itself is not responding properly. The Zoom also is not responding. Okay, I'm sharing the screen now with the block and tackle. Let me know when you see that screen, because I think it is freezing a bit. The Zoom itself is freezing. See, now we understand one thing. Before we start, I remember you all telling you, I showed you a block and tackle. If there are odd number of pulleys, I told you where is the fixed point of the strand. And I recall telling you all even about when it is even number of pulley, where is the fixed point of the strand. Do you recall me showing that? Yes. Do you recall me showing it?
So could you repeat?
Last time, if you remember, I showed you the pulleys, and I told you that where should be the fixed point of the string.
Yes,
Okay,
sir.
and in even an odd number of pulleys. Can you recall that? Because I'll be sharing otherwise then, if you do not recall it. Should I share it?
So in block and tackle, no?
Yeah, block and tackle. See, this is how it is. In a block and tackle system, when it is odd number of pulleys, your strand is here. Can you see this? Where's the strand?
So it's loading.
Fixed and it's loading yet. Okay.
It's visible, sir.
Yes, so we can see.
Yeah. So the fixed point is at the movable block. Am I correct? So your end is tied to the movable block. The block is moving. Okay. And in an even number of pulleys, it is attached. The fixed point is attached to the rigid support. Okay. The fixed block. So I repeat that in case of a odd number of pulleys, it is attached to the movable block, while in case of even number of pulleys, it is attached to the fixed block. Now here the logic is very simple. Okay. Here the logic is very simple. Leaving the fixed strand, see this, leaving the fixed strand, you have to count the number of rotations of the string. So how many rotations? 1, 2, 3, 4,
5.
and 5. Correct? 5 rotations.
Yes, sir.
So here the simple logic is 5 rotations means effort is okay applied once, but we are getting 5 times the tension of the load. It is divided in 5 different strands. I repeat. Okay. The effort, the load has been divided in 5 strands here. Okay. The tension is 5 times. So here when we speak about the load, okay, when we speak about load has 5 tensions. The load is divided into 5 times the tensions. In case of 5 pulleys. So here, if you see again, as I said earlier, okay, the load has been divided 1, 2, 3, 4, and 5 strands. While the effort, sorry, with the fixture, forget about the effort. And there is only one strand for the effort, which is what you can say, which is free end. So effort end is one end only, and it is free end. And it is means you can say balanced with only one tension. Am I correct? Because effort strand is this much. This is only the effort strand. And how much is the tension? It is equal to the one single tension. Now, if you look at the mechanical advantage, MA is equal to load upon effort. Agreed? Children agreed?
Yes, sir.
So if I want to substitute the value of L, which is 5 times the tension, and if I want to substitute the effort, it is once the tension. So what is the final answer that you get?
5.
5. Correct? So
Yes,
here the logic is very simple. I said earlier, by mistake, I said you have to eliminate fixed. Fixed is not eliminated. Free end is eliminated. Fixed is kept. So free end eliminate. For load, you eliminate the free end and check the number of strands. See 1, 2, 3, 4, 5. 5 tension bearing strands are there. Okay, for the load. And one strand is bearing the tension of the effort. So one strand with the effort and 5 strands with the load. And therefore, the mechanical advantage is equal to 5. In this case, how many strands are bearing the load?
4.
4, correct? Agreed? So here, load has 4 times the tension. Correct? Here in
Yes,
this case.
sir.
This is here, sorry. So load is 4 times the tension. And effort again is one free end only. How many strands of effort? There's only one strand of an effort. So effort is equal to once the tension. Agreed?
Yes, sir.
So now what will be the mechanical advantage in this case?
4.
4.
4.
Is equal to 4. So in general, how would you summarize the mechanical advantage? How would you summarize the mechanical advantage?
The number of pulleys.
Equal to the number of pulleys, correct?
Yes,
So
sir.
here the total number of pulleys are 5. So your mechanical advantage is 5. In this case, it is 4. So your mechanical advantage is 4. Correct? So this is how we calculate mechanical advantage. And now, if these are ideal system of pulleys, if it is ideal system of pulleys, do you agree that MA upon VR is equal to 1? If it is an ideal system of pulleys, efficiency is 1. Am I
Yes, sir.
correct?
Yes, sir.
If the efficiency is 1, what will be if I substitute on the left side? The mechanical advantage was 5. So what will be VR equal to? Yes, what will be the value of VR? Tell me. Children, I hope you all are able to see what is there on the screen.
Yes, sir.
Yes, sir.
Yes.
5.
Yes, 5. VR is equal to 5. Simple logic. Why VR is 5? Simple. There is a expression in front of us. Correct? There's an expression which is there in front of us. We are using the expression 5 upon VR is equal to 1. So VR is equal to 5. In this case, on the other side, what will happen? In the even number of pulleys, what will happen? What will be VR equal to?
VR equals to 4.
4.
Because 4 upon VR is equal to 1. Hence, VR will be equal to 4. Simple logic. So this is what is, and we are speaking about ideal ones now. What are we speaking about? The mechanical advantages for the pulleys ideals, pulley system. Now let us think of machines which are not ideal. Let us think of machines which are not ideal. What happens then? In machines which are not ideal, what happens? Can you tell me?
Sir, the efficiency will not be 100%.
Efficiency will not be 100%. That is 1 or 100%. Am I correct?
Yes, sir.
Okay. Now, take this example itself, block and tackle. Chalo, let us take this example itself, the block and tackle example. In the block and tackle example, if you see carefully, effort is it the effort only being applied to lift the load? Ideally, practically. Ideally, it is we are using only for lifting up the load. But do you feel it is only used for lifting the load, your effort? Do you feel the lower block has no mass?
It has.
It does have. So the total load that we are applying the effort onto, is it only the object that we are lifting up, or it's the object plus the pulley that we are lifting up?
Object plus the
pulley.
pulley.
Correct. There are two pulleys in it, and we are lifting up those two pulleys. Forget about this also. Even if you consider the combination of pulleys, if there are two movable pulleys and there's one fixed pulley, we are applying effort. Do you feel only the load is being lifted and the pulleys, the mass of the pulley is not taken care of?
No, sir.
It has to be taken care of, correct? It has to be. And therefore, in practical use, in practical machines, the entire effort is not utilized in overcoming the load. Agreed or not? But the effort has been divided into two parts. One is the load and one is the overall mass. Say, for example, the strings plus the pulleys. Correct?
Yes,
Agreed
sir.
or not? So yes, no doubt, we can say the effort that we apply is the tension that is on the rope. Effort is equivalent to the tension on the rope. Correct? We are taking about, but how much is the tension on the rope? That is important for us. So the total tension, for example, in those number of pulleys, in this case, okay, it was load was equal to n times the tension. Am I correct? As many strands, that many multiple we got. Because in 4 pulleys, we had 4 time tensions. In 5 pulleys, we have 5 times the tension. So n pulleys, how much will be the tension? N times the tension, correct? But is it the load of the pulley itself? No. We are also considering the weight of the pulley. Load and the weight of the pulley. Now that is equal to the tension across the strands. Correct? The total tension on the strands is not just the tension of this load. It is along with the load, it is also the tension of the mass of the pulley, that is the weight of the pulleys. So this together gives us the total tension on the strands. Agreed?
Yes, sir.
So what will be the value of load now then? Only load, if I want to only consider load, will it be n into T minus W? That is minus the weight of the pulley system, of the movable block. Agreed? Yes, do we agree or not? I've just
Yes,
taken
sir.
W from one side to another. Now, what is mechanical advantage given as? Let us see. What is the value of mechanical advantage? MA is equal to load upon effort. Correct?
Yes, sir.
So this is the load and effort is only T. Am I correct?
Yes, sir.
I would, instead of saying this, now I would take, instead of T, I'll take E, because E is equal to T, correct? So in place of T, we have clearly said here, E is equal to T. So in place of T, I am substituting E. Wherever T was there, I have substituted E over there, correct? So now tell me, if I want to distribute that E, if I further distribute it, okay, like this, what will happen? What will be the reduction in this particular thing?
N
The
minus
E will
W
get
of
cancelled. E will get cancelled. Am I correct?
yes, sir.
And we are left with what? N minus W upon E. And this is the actual mechanical advantage of a practical block and tackle system. So do you agree, if I am subtracting something from N, it means it should be less than N? I'm subtracting a number from N, correct? Weight cannot be negative. Effort cannot be negative. So there is weight, there is effort. Okay. So if I take the if I take the fraction, it might be in 0 point. It might be not greater than 1. It might be less than 1. Correct. But still it has to be subtracted even if it is 0.5, for example. For a while, let us consider the value of W upon E as 0.5, just for a while. Or let us consider not even 0.5, I'll consider it as equal to 0.2 for a while. Very like negligible mass of the pulley system, negligible weight of the pulley. If it is 0.2, okay, tell me what will be, and if I'm considering 5 pulley system, so what will be the mechanical advantage?
N minus W1.
Is equal to 5. N is 5 minus 0.2, which
Yes,
is equal
sir.
to 4.8. Agreed? Agreed or not?
Yes,
So is
sir.
it less than 5? Is it less than the number of pulleys?
Yes, sir.
Correct. Now, if I try and calculate the efficiency of it, okay, if I try and calculate the efficiency, how do we calculate the efficiency?
Load by number of pulleys.
Load by number of pulleys, correct. Efficiency, MA upon VR. Efficiency is calculated as MA upon VR. Now, velocity ratio will not change. Did I tell you that earlier also? If you remember, there's only one
Yes,
quantity
sir.
which remains constant, that is velocity. So, velocity ratio will remain 5. It does not change for this system. Okay, we are not changing anything else. Okay, but what is the only part is because it's a practical machine, we have it as 4.8 upon 5. Mechanical advantage is less than 5, but the velocity ratio is equal to 5. So, what will be the answer?
0.96.
96, correct? So I have taken the highest possible thing. Okay, I have taken only the mass such that you are getting an answer as 0.2. In fact, when will you get the answer as 0.2? You know, when the mass is 1 kilogram against the 5 kilogram effort being applied. Do you feel 1 kilogram pulley will be able to lift up that 5 kilogram mass? No, and the other things are also there. The strands, the mass of the what you can say, the rope and all. So it surely has to be more than 0.2. Agreed or not? The W upon
Yes,
E
sir.
value. Agreed or not? Do you
Yes,
agree
sir.
with this or not?
Yes, sir. Yes.
So here it is showing 96%. 96% is too high actually. Actually, the efficiency is on a higher side in this case, according to my consideration. But actually, W upon E comes something round about 0.8, if not more. So even if it is come as 0.8, we get 4.2 upon 5. That is at the most how much? How much will be 4.2 upon 5? 8.4. Sorry, 0.84. That is 84%. Correct?
Yes,
Yes, sir.
sir.
So that is approximately what you get the efficiency of a practical block and tackle system. I'm again speaking of practical block and tackle system. And therefore, for us, this equation becomes too much important. Either you call this equation or you call it as, in fact, I would say this one. This one is a very much important equation for us, expression, that the mechanical advantage of a practical block and tackle is equal to N minus W upon E. Okay?
Yes.
Understood? Okay. Now, the same equation, if I divide it by N, because N is the velocity ratio, agreed or not? So our equation was MA is equal to MA is equal to N minus W upon E. This was our equation, correct? This is our equation expression that we have got. Now, if I divide it by VR, eta is equal to MA upon VR. Do you agree?
Yes, sir.
And VR is equal to N, equal to the number of pulleys, correct? For a block and tackle system. Agreed or not?
Yes, sir.
Okay, so if this is the case, I separate them now. I separate them. Now, another logic why efficiency is less than 100%. This is another logic. Now, I'm separating that n. If I separate that n, it will be n upon n, n upon n, and W upon E divided by n will become W upon n into A. Am I correct? N times the effort. Agreed or not?
Yes, sir.
Yes, sir.
So what will be the efficiency now? How will you see what is the efficiency?
1 minus W by NE.
Correct? 1 minus W by NE. Now, even if you consider this, no doubt the value of n is 4, 5, 3, correct? Into the effort that you are applying. This is another important. So from 1, if you subtract anything, you are going to get a value lesser than 1. Agreed or not? If you are going to subtract anything positive from 1, the answer will be 0 point something. Am I correct?
Yes, sir.
Yes, sir.
We are not considering the value greater than 1. We are subtracting something less than 1. But from 1, we are subtracting that. So even if you subtract 0.1 for a while, let us consider, even if you subtract 0.1, the answer will be 1 minus 0.1 is equal to 0.9, which is lesser than 1.
Yes, sir.
And hence, the efficiency is never 100%. It is not 1. It is less than 1. 0.1, if I subtract, it is 90%. How much is it? 90%. So that is the efficiency. From 1, I am subtracting 0.1. It becomes 90% efficiency. So that is what is important for us. Okay. So in a block and tackle system, if you increase the number of police, remember, the more are the number of police, the more will be this denominator. I'll put it in red. The more will be this denominator. But even this value will increase. Agreed? W will also increase, correct? Weight of the police. If instead of 4 police, you are using 5 police. Okay. So W will, or 6 police. We are speaking about even to even. Huh? If instead of 4 police, we have converted into 6 police system. What will happen? N has increased, but what about W? 1 pulley weight has been increased, correct, in the block. Plus the
Yes.
frame that is extended from 2 to 3. That frame also has some amount of mass, correct? Do you agree or not?
Yes, sir.
Frame will have mass. Its what you can say, axle will have some mass. So altogether there is mass in it. And therefore, if you increase the number of pulleys, still it will reduce the efficiency by less than 1. It will still be less than 1. No doubt there would be a slight increment in the efficiency, but still it will remain less than 1. Understood?
Yes, sir.
So you can use more number of pulleys, but it is going to equally require a little more amount of effort. Okay, if mechanical advantage may increase, but a little more amount of effort will be applied. That is how it is. So this is what is about the pulley system. Now, if anyone has any doubts, can ask about it, the pulley system.
Sir,
The paper is on which date is the paper? Or has it completed? I think so 28th it was, correct?
Yes, sir. It is completed.
How was it? How was it?
It was easy, sir.
Easy. Okay. Nice. How many numericals were there? That paper? How many marks it was? 50 marks?
20.
20 marks. Okay, chapter. Like how many numericals were there in the paper?
So I think 2 to 3.
2 to 3 numericals. Okay. If possible, next time just upload the image of it on the whiteboard. If you have a paper with you. Did you have a printed copy or a soft copy with
Sir,
you,
it
or
was
was it only displayed?
Google
it
Form.
was on Google Forms.
It was on Google Form. Oh. Yeah, I think so. Last time someone said about it. I'm really sorry. Sometimes spoke about it. Someone. Okay.
Sir, Banjpur has this paper from 19.
Yes, sir. On the
Yeah, they have it from
of
9.
July.
Yes.
So we have do not have Google Forms anything, and it is for 30 marks.
For 30 marks. Okay.
Sir, we are
Which-
having force, work, energy, and power.
Force,
Sir,
work,
but
energy, and power.
Sir,
Means
but
two
not all
chapters.
modules are going to be taught. Only module B. Module A has been taught to us full, but module B till where our teacher is going to taught us, till there only the paper is
Okay,
going to come.
so whatever completion takes place, only till that it will appear in the paper.
Yes, sir.
Okay.
Yes, sir.
Who is teaching you all physics in Barnes?
Sir,
Miss
Miss Charlotte.
Charlotte.
Sorry,
Charlotte.
Miss Charlotte.
Okay, Charlotte ma'am.
Excuse me, sir.
Yes, Devishi.
Sir, I am in Podar and our exams are starting from 5th of July.
Okay, 5th of July. Now, what is the syllabus that is there?
Sir, in physics, we have calorimetry, refraction through light plane surface, and refraction through lenses.
We have completed refraction to plane surface, correct?
Yes, sir, we have done.
We are
Yes.
done. Okay, so what do you want? You want calorimetry or refraction of light through the lenses?
Sir, refraction through lenses.
Through lenses. Okay.
Sir, I
Till
just
then,
wanted to ask
I hope.
something.
Sorry.
Excuse me. Sir, I
Yes.
just wanted to ask, sir, I am having some doubts in numericals from chapter 1, module A, and chapter 2, module A numericals.
Fair enough. What will we do is, Shantanu, on Sunday we have a session regularly, correct?
Yes, sir.
So after we finish our session, do you have any other sessions aligned after the physics session gets over on Sunday?
Nothing, sir. Sir, after that, I'm free for whole
So
day.
what I'll do is I'll give you that 10 minutes for this doubt solving of numericals on Sunday.
Okay,
Fine?
sir. Yes, sir. Thank you, sir.
Because now I am more interested. Rather than interested, I'm more worried about completing the syllabus for others also. So Podar, there are 2 chapters actually, and I cannot cover all 2 before 5th of it, because today already is the first. Okay, I'll just check if sir can align one more session, maybe somewhere in between, and then I can do it. 5th is what one? I'll just check what is the day. 5th. 5th is Tuesday, I believe. No, it's Monday itself.
Sir, but physics paper is on next Monday.
Okay, so in next week, sir, Omkar sir, are you there?
Yes, sir.
Sir, in next week, Thursday and Friday, can I get a physics session? And this Sunday, anyways, I need
Definitely. Friday, I'm not sure.
Saturday then.
Sir, I'll really have to see. I'm not sure because the slots are full actually for now.
Because they have their 2 chapters to be completed. It's a
Yes,
little
I know,
bit-
sir. I have sent her the videos of Prashant, sir. Actually, we have some videos. So I have sent her videos, but you can definitely, as much as possible, you can teach her. So this Sunday, you have a lecture anyway for, so we can extend that if you want, because computers will not be conducted this Sunday. So we can have a 2-hour session as well, or
Fair
90-minute
enough.
session. 2 hours may be heavy, but you
Fair
can
enough,
take
fair
90-minute session this Sunday,
Fair enough.
10 to 11.
Agreed. Completely agreed. Okay. So this Sunday at least we'll have a 2-hour session. Then let us see what happens the next week. We anyways have the regular Thursday session coming week. Okay, let us come back. I'll straight away, without wasting much of time, I'll straight away come refraction. So till now we saw it. Before I start again, I would recall myself. Do we have any doubts in police system now? We have completed the machines chapter. Not only police, any part of the machine chapter.
No, sir.
Anyone?
No doubt.
Apart from numericals, sir?
Sir,
Apart
it was
from
easy. Sir, it was easy.
easy.
Sir, I have a doubt.
Who has a doubt?
Sir,
Yes,
Aditya,
Aditya.
sir.
Yes,
Sir, as
Aditya.
you said that the frame and action also have weight. So then, why is adding much more footage to the fuller system of footage is much more effective?
See, that's what I'm saying. It is going to increase the weight, but the weight is not going to increase that much as compared. So usually when number of pulleys are increased, movable pulleys, we are increasing usually. Movable pulleys will help us to reduce the efficiency, the effort being applied. So more number of pulleys will always reduce our effort. Okay, no doubt coincidentally there, the weight of the pulleys are being added, but that is not huge amount. There is weight. I just wanted to signify that there is weight of the pulley. There is. But it is, if you add one more pulley, it is not a very significant rise in the increment in the weight of the pulley than the number of pulleys. Because n is going to increase, so denominator is going to increase by one complete factor. Whereas your pulley, when you increase, it is hardly going to 1 kilogram of the 5 kilograms or half a kilogram of the 2 kilograms, whatever is the case. Am I correct? So it's not going to have a drastic improvement in the numerator. The denominator has a better improvement. So automatically the fraction will reduce. So 1 minus smaller fraction will give you a little better value. So instead of I getting 1 minus 0.2, I will get 1 minus 0.19 or 0.15. So it will become 0.85, 85% efficiency instead of getting 80% of efficiency. Are you getting me?
Yes, sir.
So that is the reason why number of pulleys increase will always try to improve the efficiency of that particular system. But the only thing is, it will not go beyond 95 or somewhere. It is not going to happen because always the weight is going to be there. The pulley weight is always going to be there. And also then the rope has to bear the tension of these number of pulleys. So if more number of pulleys are added, then the rope also has to be what you can say, strengthened. That means you'll have to use a thicker rope. Correct?
Yes, sir.
So that is the reason why the pulley system increment in number of pulleys will increase the efficiency certainly, but it will never cross that 95-96%.
Yes, sir.
It can approach there. It can approach up to there, but it cannot cross it. That's what it is. It is never 100%.
Okay, sir.
Yes.
Thank you, sir.
Yeah. Anyone else?
Sir, I just wanted to ask,
Yes.
sir, in gym workouts, they use that some type of pulley. Sir, it
Yes.
also. Yes, sir. I'm not able to understand. Sir, they add about 50 kilos weight, and how that small single wire is able to stand.
See,
it.
that single wire, that is a wire, and it is actually it has a unique technology in between. Inside there is a strong system. If you see those heavy weights, have you seen those most workouts, bigger workout things like this block of square block which has heavy pulleys in it?
Yes, sir.
Correct. Now there are multiple gears in it. We have not studied gear system. There are multiple gears in it, and that is going to be applied on a pulley. So in that gear part, there are strong strands, and when it is given out, it gets already reduced. The effort already has gone reduced to such an extent that your thin wire can be applied at the latter part of the system.
Okay, sir. Thank you, sir.
That is the case. Even if you see those ropeways, with respect to the weight they are carrying, with respect to, they have no doubt thick ropes, correct? But even then, with respect to the length that they cover with the rope and the trolley that is there and the people sitting in the trolley, the mass is still taken care of with that particular rope. Why? Because it actually is divided. If you see those ropeways, there are multiple pulleys. So the mass is divided amongst those 4 pulleys, and that always helps. So there are various mechanisms that are taking place. They always divide this mass into various components. Here in my example, it was in the number of pulleys. There are gear system. Now we unfortunately do not have gears in our scope, but 6 years back I was teaching gears to the student. That was also an interesting concept, which was an, what you can say, extension of pulley system. The gears is an extension of pulley system. That's why we use gears in cycles. You might have heard about, you might have used cycles, and even in bikes. I won't say motorbike, others mopeds, but the bikes, actually the 2-wheelers, like which are geared ones. You might have used it. You might have experienced the freeness when the gear changes from one gear to another.
Yes, I know, sir. Sir,
Yes.
when the bike is driven in first gear, sir, after some times the engine makes some sort of
Yeah,
sound.
it becomes heavy to drive it. Like the engine feels a little like burden of driving that vehicle, correct? So you have to change it to the second gear. Then a little freed. It gets a little free. Further, it gets free. Same thing in the gear cycles also. When there is an inclination, what do? You change your gears. It gets shifted, and then you find the freedom of what you can say pedaling the cycle. Am I correct?
Yes, sir.
Yes, sir.
So that's the case.
So,
Fair enough.
excuse me, sir.
Yes.
So, but in this case, why it is said that the first gear has a maximum torque?
Why is it said that the first gear what?
Has maximum torque.
Can you type in the chat box? I'll just read that out. I'm a little. Can you please type it in the chat box? What you're saying? Maximum torque. Okay, top gear, correct?
It is said that the first gear has the maximum torque, something like that.
Maximum torque means maximum turning effect. Now, what is torque? Do you recall our first chapter?
Yes, sir.
Yes, sir.
What is torque?
The turning effect of force.
The turning effect. No, in terms of expression.
Sir, moment of a force or turning
That is
effect.
equal to
Magnitude of force
distance.
into perpendicular distance.
Correct. Magnitude of force into the perpendicular distance. So when it is on top gear, the major part of your, what you can say, the chain, which is there, is on the gear, correct? So all your force is being utilized on a major part, and therefore it will have maximum torque. So it has maximum torque means pickup. It has means your vehicle is in resting position, and you use your first gear for the vehicle to take off. Take off in the sense to start driving. That cannot happen on your top gear, correct? Do you feel that your vehicle is in a resting condition and you have already put your, those who have 4 gears or 5 gears, you have put it on the 5th or the 4th gear, and now you have started the vehicle and straight away on the 4th gear and you are starting it and trying to drive it. Will it drive? Do you really
No,
feel?
sir. Sir, it
No.
will get clogged. Sir,
Yeah, it will get clogged up. So that is the reason why your major part of the force is there on the chain. Okay, you're applying it on the pedal, that is being transferred on the major part of the chain, and so more force is being applied on the utilized on the this part.
Sir, in motorbikes, if we drive with the top gear directly, the gears will break or the chain will break off. That's the
Yeah,
main issue.
correct. Very true. Very true. There'll be damages in the engine as well. Means in the gear system, I won't say engine, in the gear system also. It might slip off, it might break off a teeth or two, and that is very difficult. Even if one teeth breaks off a gear, it's useless. You'll have to replace it. Okay, so fair enough. Shall we move on to, that is something out of scope? Shall we move on to now the next chapter? If
Yes, sir.
doubts are clear, I'll just start with, and then I'll leave it off because we still have nearly 10 to 12 minutes. Okay. Yes, now we come to lenses. Now, before we start with lenses, children, we have studied 2 types of prism. Which were the 2 types of prism we have studied?
Sir,
Yes,
are we
can
doing
someone
chapter
tell me?
5?
Yeah, I'm starting with chapter 5. Which were the 2 types of prism that we have studied? Can someone tell me? 2 broadly categorized prisms.
Pyramid prism?
We have not studied pyramid.
So that isosceles and equilateral one.
Oh, those are types of triangular prisms. I'm saying broadly speaking, what are the types of prisms that we have studied into broad categories? We have studied 2 main types. One was the rectangular prism, which was called as a glass slab. Agreed?
Yes, sir.
And the second one was the triangular prism that we studied. Am
Yes,
I
sir.
correct? So we studied those 2 types of prism broadly. The broadly category can be categorized. Now see, even if you arrange these 2 types of prisms somewhere in this type. So for example, this type. Okay, this is the prism. I I don't have a triangle, so I'll be using a. So this somewhere looks like a lens. Okay. Does it look like a lens somewhere?
Yes, sir.
Yes,
Correct.
sir.
So using, and if this is no doubt one kind of a lens, there is other kind of a lens that can also be built up. The only thing is here, now I do not have deformation. Somewhere like this, the prisms would have been used like this. So if this is the case, this is a triangular kind of a part of a triangular kind of a prism. Okay. Correct. This part is cut. The only thing is the top is cut. Then we put in a little this thing, and then we again put a inverted triangle, maybe like this, something like this. Correct. So this somewhere would look like a the concave lens. Correct. So ideally speaking, when we are speaking about lenses, we are speaking about a combination of or a homogeneous combination of prisms that we are using. We are using combinations of rectangular prisms, and we are using means combination of rectangular prisms with triangular prisms. In fact, this I have very simply explained it. It is a combination of multiple what you can say rectangular and two triangular prisms at the ends. That is actually the way the prism the lenses can be expressed as. Okay. Now, do you know what is the lens? Does anyone know what is the lens? Yes, any one of you. You can tell me what is the lens.
A piece of glass with a certain.
Yes, it is something which is made up of glass, okay, which is bounded by two surfaces, and there's a glass filled in it. Correct. But the surfaces are such that in fact, I won't say two surfaces, but yes, there's glass. And since it is made up of glass, it is acting as a prism. So we'll have an incident ray, a refracted ray within the lens, and after the refraction, the emergent ray. Am I correct?
Yes, sir.
In short, there would be double refraction. One is from air into the lens. It will get reflected within the lens. And when it comes out of the lens, again a refraction takes place, double refraction taking place. Agreed? Now, before even we start, we have studied something about this kind, some kind like something related to this kind in grade 9. That is spherical lens, spherical mirrors. Am I correct?
Yes, sir.
What are all concepts? Tell me only basics. I don't want a deeper explanation. What basic concepts did you study in grade 9 about spherical mirrors?
The concave, convex.
Concave and convex. Concave and convex. Now look at the word concave. Look at this word. I'll break into two parts. Concave. Now instead of writing E, I'm just writing one thing. Okay, either I write this or I'll write ITY. So wherever there is a cavity facing the incidence, okay, they are concave, whether it's a lens or a mirror. When the ray is incident, so this is, for example, when the ray is incident, there's a cavity where the rays are being incident. Am I correct?
Yes, sir.
Yes.
On the other way around, if I hold it this way and the rays are coming from here, is it the cavity? Is it a cavity?
Yes,
No.
sir.
So concave are those where the rays are being incident on the cave part of it. We know what are caves. Caves are what? Those are cavities dug up deep inside the mountains. Am I correct? Not very deep, but yes, inside the mountains. Those were the caves of old days. Am I correct? So therefore, that word concave is being used, and a convex. The second word which is used is convex. So if you are able to identify concave, then it is not very difficult to identify convex. Okay, so this is when I write concave. Let me move it to the right place. Otherwise, you'll say, sir, where have you placed it? Okay, so convex are those where so there are two types of even spherical mirrors. One is concave mirror, and one is a convex mirror. What difference did you all find with respect? What was the basics that you all have studied with these two mirrors, these two kinds of mirrors?
The way in which they are curved, one is inside and then outside.
You all agree that when the rays were incident on a concave mirror, after reflection, they would converge at a particular point. Do you all agree? When a parallel beam of light was incident on a cavity, after reflection, it will converge at a particular place after reflection, correct? Understand? Do you agree or not? See, like this, something like this. I'll just show you something like this. We had a cavity. Okay. This was the mirror. I'm sorry, the board is not very clear. Okay. When the rays were incident on this was the principal axis. Then the rays used to diverge at one particular point after hitting it in concave mirror.
Yes,
Agreed
sir.
or not? But in convex, what used to happen? Sorry, in convex, what used to happen?
The rays
Exactly
get
opposite.
apart.
The rays, when they were falling on the surface, they used to diverge away. Correct? They did not come at, they did not converge. They used to diverge. They used to move away after reflection. So we had to produce them backwards to check where is the image formed. Correct? For formation of image, we had to do this. We had to do this. Agreed or not?
Yes, sir.
Similar kind of thing we'll even observe in lenses also. We are going to observe such kind of things in lenses as well. We'll have to make sure that whatever we do now. When we studied refraction, what were the important components, or even in reflection? What the incident ray, the surface,
Normal
correct?
and the reflected.
Yes, the reflected or refracted, depending on what you are using. But the incident ray, the surface, the normal, and the refracted ray or the reflected ray. These were the important components of when we studied even in refraction through a plane surface, and even when we studied previously in grade 9